We have few people already joined after the starting time. So hi everybody, happy to have you all here. So my name is Piotr Biegun. I'm responsible for customer growth at RevDeBug, and together with me I have Adam Kruszewski, who is the CTO at RevDeBug and also one of the founders. So today we talk a little bit about microservices and automated tests and how you could make it easy to troubleshoot them with RevDeBug application monitoring. So today we have few points on our agenda. We start with quick intro just to remind everyone what we are doing. Later on, we move to the common problems with microservices. It's our observation and things we heard here from our customers. And later on, we move to the technical demo when Adam will show you how to solve integration errors in microservice apps, how to set up monitoring for JavaScript application, and how to troubleshoot failing automated tests. And after that, we answer your questions. So if you have any questions, you could write them directly in the chat, use QA. And if you particularly like something, you could use reactions and add emojis to tell us that this is something you think it's very, very cool. All right, so starting from the beginning, RevDeBug is an observability platform that makes it easy for developers and IT teams to monitor, help, and respond to issues in distributed application. And we go beyond traditional APMs and error monitoring tools because we are able to provide automatic end-to-end tracing with visualization of the root cause and the path for each error. So basically, we could show you code execution from each failed transaction from production or test environment without any significant impact on the performance. So this is pretty unique for us because it goes beyond typical APMs or error monitoring, and because we are able to show you exact path and the code execution for each failed transaction, it makes easier for you to troubleshoot applications. Right now, we support application written in Java, C#, Python, and JavaScript. Everywhere you could run this code. So if it's on-premise, in cloud, or even serverless functions, it all works out of the box and with minimal time spent on instrumentalization. So basically, what you should, I think, remember from RevDeBug is that we can provide you with production debugger, which is always on without any common issues of the production and you know about production debugging. So Adam will show you exactly what we mean by that. And right now we move to the microservices. So I would like to hear your opinion. So you could type of observation in chat if you have any. But what we hear are different stories, and for sure, microservices are great when you are looking for a way to increase delivery speed. You need to provide rapid and easy scaling for your application, and you work with many external APIs, and you need to solve issues with managing many data coming into your application. What is funny and what you could hear from companies which migrate to microservices is that they had more benefits from rewriting their application, not just implementing the microservices. So this is one thing I think you should reconsider when you think about migrating to microservices, because the harsh truth is that they are hard, as any complex system. It's like example here. This is the plant architecture for Uber. In the end, it looked like that. So around 2,200 microservices, which are really hard to troubleshoot, hard to configure. They can increase delay in your application and impact performance. And because they increase complexity, it could have you could have problems with tracking data going across your applications and transactions. So what we hear from and what we observe from our customers when they troubleshoot microservices the first thing they started to see is that they are getting additional complexity, and they are starting to get new type of problems, integration errors. Even if before migrating to microservices, they didn't have any additional or special integrations, because the complexity and different data flow makes creates data inconsistencies that you need to understand and solve. And another thing they notice is that the causes and the symptoms are in different places. So you have errors, and they don't have any clear path to reproduce, because this is I think also what you could experience on your own. It's like you miss logs, or you have too many logs that doesn't mean anything to you. And this is the funny stuff with those logs, because the worst errors are those errors which are unlocked, but we are not adding logs because we don't know if the code is broken. Because if we know if it's broken, we'll fix it. And in the end, those problems complicate debugging, root cause analysis. It's a very thin line between performance, infrastructure, configuration, and software. And finding this could be problematic if you don't have proper tooling. What we also notice is that you could end with projects that have anti-patterns, with too many dependencies working in not the best way, or covering some kind of technical debt. And this makes really hard, because those microservices aren't really microservices, and they cover something that shouldn't be called as a microservice. And in the end, we see that everything is harder to test. The problems are harder to reproduce, because on top of that, we have differences between development and production environment, staging. We have different configuration, different data sets, and some functions or some workloads cannot be easily recreated. In the end, so RevDeBug is here to help you simplify this troubleshooting, and Adam will show you in just a few seconds how you could use RevDeBug, how you could benefit, and how it helps you in solving problems with microservices and automated tests. So Adam, it's time for you. I'm giving you the screen. So tell us more about the technical stuff. Yeah, and
let me take over the screen.
Yeah. All right.
Okay, so my screen should be visible now. Yeah, so before I will start, I would just go very quickly to show you the architecture of RevDeBug and where its elements are actually running. So the central RevDeBug server that gathers all of the metrics and the recordings of the execution of microservices or other applications actually is something that is run on premises or in your own cloud tenant. So we do not have we as RevDeBug, we don't have access to the data there. It's totally belongs to you. So that's something you have to deploy in your own network basically. And I will very quickly show some pointers how to do it. It's very simple, like 3-step solution. Next thing you also have to do is to add RevDeBug dependencies to the projects that have to be monitored by RevDeBug. And RevDeBug, for most platforms, adds itself to the application during its compilation or packaging phase, so before application actually runs. And after that, RevDeBug becomes an integral part of the application, so you deploy that normally as you do. You don't need additional services or elevated privileges for RevDeBug to work on. One more additional thing, of course, is that RevDeBug does need a read-only access to source code repository to show the code recordings, the application recordings on the source code, which I will also show you in a minute. So, and Piotr will also put the link to the documentation where everything is described as well on the chat. My demo will have two basic parts. One will be I will show you how RevDeBug can help with troubleshooting and actually finding responsible path for errors in microservices environment. The second part will be I will add RevDeBug to a JavaScript, Node.js, and Vue application, and I will run that on a separate RevDeBug server. I will also quickly provision on Azure virtual machine, and I will show you how RevDeBug can help also trace to root causes of errors reported from automated tests. So when they fail, to be able to find the root cause of that. So first, microservices. I will demo a microservice application hosted on Azure cloud. It's a hybrid technology application, so there are parts in Java, there are parts in Microsoft.NET Core. There is a PostgreSQL server also involved as a database, and there are some calls to third-party services, to services that the team for the demo does not develop. So I have switched to this demo instance of RevDeBug where it monitors this microservice based application, and after logging in, what I can actually see is I can see the overview of all of the microservices monitored there. I can see the global response times and the heat map of how those microservices, those response times are available to the users. From this, of course, I can drill down to a particular service, so I can actually go through and see a given service, how well it responds, the loads, the slow instances that this service have, and just see how the overall look of this works. I can then, of course, also go and see how well works the particular instance of this service, and I can delve even further down the right, so I can see the particular endpoint, the business method of this web service, how it well performs. Also, of course, as those applications are using and calling the databases, I can also see how the response times of those databases are affecting our application performance. The web browser part I will show you with the JavaScript demo I'll be showing in a second. So I will go here to the topology. So automatically, also transparently from the developer point of view, after running application with RevDeBug dependencies, RevDeBug starts mapping the connections, so the real architecture of the application. And here I can see already that my microservice application, it does use some external services. This is one, this is second one. There is a database server here, and I can see my that 5 of my services are definitely not meeting the service level service levels I have assigned them. So, for example, this one is 9946. That's actually meeting the criteria. This one is lower, and the invoice sender, I can see it's way out, far away from the limit I actually set up. And this microservice application, it processes some orders and sends the invoices through email at the end of the day. And I see that it doesn't do its job. So to diagnose this problem, I will look at all of the traces in this microservice application. So all of the distributed transactions that's happened there, I will limit them to only show me the error nodes ones, and let's maybe choose them 1 hour from now. So right now I see all of the error nodes transactions that involves this particular service. I can see that, yes, there are a couple of them here, and I can see this transaction involves 5 other microservices here. They are all color coded. Those colors adhere to the microservice mentioned here. I will maybe switch to a different view because it's just easier to reason about the connections and the calls that are being made here. So I see the first microservice calls 3 other microservices, and this microservice calls the third one and a fourth one. The fourth one is reporting an error. Of course, connections to databases are also traced and present here. My security settings does not allow to actually store the parameters, but this can be done as well. So what I can see, I will start with looking at the details of the error in the invoice sender microservice. So the one that does not send those invoices it should send. So apart from the usual suspects, the stack trace, the logs, so for example, I can see here that this definitely looks like a custom error handling code. So because that's not a generic message. So let's look, and that's a unique value of RevDeBug. I can actually look inside that microservice, inside the source code that was executed when this error happened. So right now I'm accessing the recording of the execution of this microservice. The source code here is loaded directly from the Git repository with the proper release that this release code was deployed. And I can see in the C# microservice that indeed the custom error handling code was triggered, and with those arrows I can actually verify the previous steps before the error was reported, previous steps, and I can actually verify that indeed the invoice data that was sent here was empty. So from developer point of view, this microservice in isolation, of course, worked actually properly. Yes, it worked properly, but the whole business process does not. So what I can do now, I can actually enter the recording of the previous microservice. So the one that sent this empty data, which it shouldn't definitely do that. And that's actually a Java microservice. And I can also go back in time, line by line here. I can verify that indeed the invoice data was empty. And if I will go further down the line, I see the first clue of what happened here. I can see that if the discount is larger than 100%, which is definitely not what we would like to have, the item on the invoice is skipped. So let me search through this recording and see all of the discounts that were present. So basically each iteration of this loop will be here. And I see that all of the items on this invoice were indeed discounted for more than 100%. So definitely not what we wanted. But this microservice also got this data from the previous one. So I can also go access the previous one. Let me search this one for the discount too. And what I will ultimately find, if I will just go through all of that, is that this microservice also got this from the first one. And the first one, okay, let's search for the discount stuff here. Okay, and the first one also got this errors data from the discounter service. So the discounter service actually in this demo is our mother company microservice. They do the customer relationship management, just expose the data with this discounter microservice here. So they definitely are responsible. They definitely have an error there. We are not monitoring their services. They're independent. But in a very short manner, I was able to track down where the responsibility actually lies and what. So our system is blamed because this business process is not completing successfully, but the responsibility is actually on the third party from our point of view. Okay, so that was what I wanted to show you for these microservices and how RevDeBug can help in microservices applications. So now I will go to show you how easy it is to apply RevDeBug to, in this example, JavaScript application, and how easy it is actually to run RevDeBug server itself. So let me go to my second desktop here, which I have prepared for myself. So running the RevDeBug instance, and I'm just accessing the documentation here. Running the RevDeBug instance, your own RevDeBug instance, is basically you're required to clone a public repository with the Docker Compose project that holds the RevDeBug server description. And maybe I will just show that I have actually cloned that repository here. So it's very actually short list of files. So this Docker Compose project, there is the environment template that you just have to copy and customize to your needs, and then we just run the Docker Compose app. So let's just go and does that, and it will bring all of the containers up, and the instance will be operational right away. So you can actually do it in few seconds. For the demo, I will use a JavaScript, Node.js, and Vue. It's a hybrid application, so there's a front end and a back end in JavaScript application that's also publicly available on our GitHub repository, and it does have a following along README that you can actually go through that. But before that, let me access the server, which is have bring up. It will be empty as expected. Okay, so I will switch to my fourth desktop here. I have already cloned the repository to save the time. I have done the first three steps. So I have added the registry, our registry for the npm packages. I installed the packages and added the RevDeBug package there. And also I have added the configuration file. So basically, after adding the RevDeBug package to your application, you also have to provide the configuration file that will tell RevDeBug actually the layout of the application and where to send the data. So I already set the host to send the data to the new server I just brought up to speed. And I also have two sections of the configuration here, one for the server, so for the Node.js application here. So I just set up, and that's all of those instructions are described in the documentation for JavaScript stack. And so it's pretty straightforward. So the name of the application, the type of the application, the files of the application. So it's pretty simple. The application here is a SQL console, a very simple SQL console, web-based, where you can enter the SQL commands. It will send to the server, execute on the MySQL server, and it will just return the data in the JSON format back to the web browser. The client side, as it is a Vue application, I enabled the Vue integration. I set up the target type of the application to web. There are a few types of integration with web application. I will go with modules, so it basically produces the JavaScript files. For that, I also need to provide the main template that is used in the application where this JavaScript file will be included. And also I have to set up where the application files resides and what the files basically are. So all the JavaScript and Vue files are being used for the RevDeBug. And going back to the documentation, what I need to do is to right now run the instrumentation. I will do that right now. I'm not using the host switch because I added the host to the configuration file already. So I will launch the server side, I will launch the front-end side, and I will go back to my web browser. Let's maybe just open a host, and I will access the application here. Okay, so let's give it a little bit time to spin up, and we will be able to enter the SQL queries here. So for example, show status, let's just go for the show status here. So I basically executed the MySQL show status command, and I got lots of the variables that present there. Additionally, I can refresh my my APM instance, because all of this data was already sent to the server. I will go back to that. Or maybe I'll just go through that as well right now. So even with this very short usage of the application, I can see in the web browser tab that my application actually started sending the metrics of my usage. So I see my application, I see the version, the current version of the application, and the current page. The current page actually is quite useful when we will go to the pages section. So I can see, of course, the top hot pages. So there's one page application, so it's one. Top unstable pages, when the errors are happening. Also for the application, the load times. So for services, backend services, we show the response times of this microservice. For web applications, for web pages, we actually get that split to other factors. So we also see, for example, when the client was had the page ready, and they are also, of course, split for the percentages, so you can actually see how many of the clients and the like see those response times. Okay, let's go back to our application here, and one more thing, I will just go here also for this follow along shipping. I will copy the Cypress integration snippet. I will add that to the old Cypress, because I have here a few Cypress end-to-end automated tests. I will add that to Cypress support index HTML file. What this does is it instruments Cypress that when when the error happens in the test, we are basically referencing the application that is being tested. It's testing the iframes in the Cypress case, and we use RevDeBug API here to add last trace ID to the error message. So we should see the last error message with the RevDeBug trace ID, which will allow us to actually go to the RevDeBug and see this trace for this test. So let me refresh my Cypress test runner here, and I have 4 tests for this application. So I will just run them sequentially, and I will just make a full screen of the test when it runs for all you to see, because the small window can have those fonts really tiny. Okay, so I can see the first test that basically uses the application to create a table have run successfully. Let's go for the second one. The second one fills in the data in this table. It just adds, it is a tasks table, so it just asks some tasks. Some of them are completed from the definition on, and some of them are not, just for us to query that in the next test. So we will query the data here. The query data automatically queries this SQL table, fills the completed tasks. So it just sends the select asterisk from the tasks where is completed is equals 1. The second test does the same for the not completed tasks. So you can see that those tests actually failed. So the first one expected in the result to get the read morning brew task to be returned. It didn't get anything. The second one for the not completed task actually waited for the feed the cat item, and it also have returned nothing. So from our point of view, that's a symptom. That's a symptom of a problem, and the automated test found that for us. So what I can do now is, because of this Cypress integration we just add to the application, I can copy the RevDeBug trace ID. Let me go off full screen and let me go back to my RevDeBug application. I will then search for this trace ID to all of the traces that were recorded, and I can see the trace of this particular part of the test, and I can see that I have indeed recorded the client side and the server side execution. So let's go and go from the bottom upwards. Let's analyze that. So if I will click on the MySQL query that happened from the server side, I already see that there is a problem. There is a problem because the SQL query that was passed to the SQL server is, of course, does have a syntax error. There should be asterisk, not the percent here. Let me go back to the test, and I can verify that the test case actually entered the asterisk here. So this data have changed since the entering, since the data was entered to the text box somewhere in between to sending to the SQL server. So let's go back and let's analyze that. So let's look at the recording of this JavaScript application on the server side. So as this is a pristine version of instance of RevDeBug, I haven't connected actually a GitHub repository, so I can't see the source code. So let me copy the repository address and let me just add that here. Let's save that and just open the recording again. So right now I will see the recording overlaid on the source code of the application. So going back in this execution from the error that happened, I can actually see that this connection to the database and the query got indeed a wrong query in the parameter, and it originated directly from the request from the query parameter that was sent from the client. So the problem is not on the server side. Server actually just got the data and just passed it verbatim to the SQL server. Okay, so what happened on the client side? So let's look at recording on the client side. So if I will look at the recording on the client side, I know that I am looking for the percentage sign. So let's search for that, and we'll just have everything gone there. So let's go and start also from the end of the recording. So I can see that the client indeed sent the parameter with the wrong syntax. I see the trace of this SQL command. I see that at this moment in time of this execution, the wrong command was introduced. And of course, I can see that the percentage that I am probably interested in is here. So what this code does, it iterates through some translation table and replaces some queries. The query string, and if I will just go back a step, it replaces some regular expressions to other strings. So it's a classic example, yes, of the old joke that if you have a problem and you think, oh, I will use regular expression here, now you have two problems, yes. And of course, I can very easily track this translation table to this part of code, and I can see, yes, indeed, someone probably wanted to make it easier to write like queries, SQL-like queries, to use asterisk, not percentages, and it introduces an error for the whole query. So it shouldn't be done like that. So removing this line of code will actually make the test pass. But that was just to show you how easy it is to add RevDeBug to JavaScript application, how easy it is to actually spin off the RevDeBug server and use in your own environment, and how RevDeBug can help trace automated, end-to-end tests failures and find the root cause of that through the full stack of the application. One maybe more thing I'll also switch.
What I wanted to ask you.
I'll also switch here. So let me just change that. One additional thing that also RevDeBug gathers from the JavaScript, from the web browser side, from the client side, are the errors that happens in the application. So if I will open the web console here, the errors that are logged here, which most cases users are not reporting, are also caught by the RevDeBug and sent to RevDeBug server, so they can be also viewed here. So we have the executions of the code. We also have the logs and the traces of those basically distributed traces of the whole application stack. Yes, so that's what I wanted to demo and to show you today. I think we can move to questions and answers, Piotr.
Yes. So Adam,
let me stop the screen, sir.
Yeah. So before we move to the Q&A, thank you for the presentation. I have a few questions already. So yes, the recording will be available later. We'll send the link tomorrow or top on Monday. So be patient. You will get a link to the recording, and you could share it with your friends. So we also have questions about the roadmap. The first one, Adam, is when will you support Python 3.9 for one?
Yes. So actually, we have already support for Python 3.9, so the latest stable version, and it will be released in the next few weeks. After we'll finish the extensive testing we do. So it's coming very soon.
All right. Another question is about support for Ruby.
Yes, so we plan support for Ruby and Go applications. So it will be actually done in 2 steps. The first one will be the collection of the metrics and the traces and the topology. So this will be first released for those platforms, and the second will be the full recording of the backend services written in Ruby and Go as well. So it is on our roadmap, and hopefully it will be further down the line this year.
Yeah, all right. I have another question. So does RevDeBug have impact on trace application, and what is the impact on the performance? So
yes. Great question. Yes, RevDeBug. So comparing to other tools like logging frameworks or other APM kind of tools, it's actually very comparable, and in many cases faster. What we were able to do, and I hope I was able to convey that information in the demo, is we have shifted the heavy lifting needed to analyze the application, and what actually it processes and how to record that to the compilation phase. We do all of that heavy lifting there. That's why RevDeBug is, you have to add it as a dependency to your project and build RevDeBug with it. So what happens on the runtime is just the minimal storing of this information, and we only store it actually when error happens. So it's not, there's no information bias, and there's no overload of this information stored if it's not actually needed. So it's very comparable to other tools, other monitoring tools.
All right, another question about supported languages. So what JavaScript frontend, what JavaScript frameworks are we supporting? And also another connected with this one is what version of Node.js are we supporting?
Okay, yes. So we do support, so for the framework, front-end frameworks, we do support Vue, React, and Angular. Also, if your application uses TypeScript, we support TypeScript as well. So your application can be Vue TypeScript, for example, React TypeScript application. We support that, and we support Node.js starting from version 10 upwards. So it's I think we cover most of the applications running on the market.
Yeah, so maybe someone else has another question. I see question about databases. So how do you monitor databases? What databases are you supporting right now? Okay.
Yes. So RevDeBug monitors queries and comments sent to the databases from the application side. So if the application is monitored by RevDeBug, queries that it sends to the databases and the replies it gets, that's what we are monitoring and recording. So basically, what is the impact of the database on the application? And that said, depending on the platform, we basically support in most cases at the generic database interface. So most of the databases the most commonly used, so MySQL, PostgreSQL, Oracle, Microsoft SQL Server, and the like, and also NoSQL servers like MongoDB are supported as well.
Okay, and the last question I got is before I have my one at the end. So where do you store data, and is it secure?
Yes. So RevDeBug is rolled out in your own, so in clients from our point of view, infrastructure. So it can be on premises or in the cloud tenant of the client. It's completely in the control, in the network control by the client. So we do not have access as RevDeBug to it, and data, all of the data is stored there. Additionally, of course, RevDeBug can be configured to not record particular data. Yes. So for example, if you have some sensitive data, you might exclude that from being recorded. That of course requires some domain knowledge, but it can be done with a configuration file. As I was actually, I was showing the configuration file. You can actually add the exclusion patterns there. So it's all that you are controlling. We are not having access to this data at all.
Any additional mechanism on our side, Adam? So any integration with LDAP, all this kind of stuff?
Yes. Oh, yes, of course. For enterprise installations, we do support integration using actually an open source authentication bridge called Keycloak. We can authenticate. We can integrate with Microsoft Active Directory, Azure Active Directory, LDAP services, and many other single sign-on services, OpenIDs, SAML2 based and the like. So basically anything that you can run in enterprise, we can plug authentication and authorization in it and map the groups you have to server roles at RevDeBug, because all of I was showing is guarded by a role-based system. So you can tweak that. So some developers that do have some, I don't know, NDAs within the company can access the recordings, and some other can, for example, see only the performance metrics. So this can be done for the enterprise installations as well.
All right, I don't see any questions. So if anyone has additional questions, just type them in the chat or the Q&A. So Adam, what's planned next? So what are you working right now, and what are you planning to release in coming weeks?
Yes, so we plan to have on one side, from the installation point of view, we plan to have one-click installation on the Microsoft Azure cloud. So if you use Microsoft Azure, you will not have to type those three commands I shown in the documentation. You'll be able to actually deploy the application with one click on the Azure directly. Additionally, we also going further from the JavaScript and the web browser recording we also will provide a UI recording. So basically a video of what client was, how he was seeing the application and how he was using the application apart from the code. So the UI, the visual side of thing, because what we are seeing sometimes is the common question for the developers, for the business user, are what you have clicked, how you have clicked it, how you have used the application. Additionally, some of the plugins inside the web browser can change the website view, like ad blocks can actually remove parts of the application. And with that functionality, we'll be able to provide those answers, to provide a video how the user was seeing the application and how he was using this application before the error happened. So that will be also released in the upcoming weeks.
Perfect. So I think